Hello again. We're back. Substitution, except special case systems, and I want to show you this because when students get these types of answers, even when they do elimination, which we're going to do next, they get confused and flustered and say, throw down the pen, I didn't do this right. No, it's not that you didn't do it right, it's that I'm trying to get you to think and do problems that are just typically outside the box. And that's the way you really learn your math skills, when you try all sorts of problems, and not just the one particular type of problem that you're used to doing. So I've got this one problem right here, y equals x plus 2 and y equals x. Actually, y equals x is also the same thing as y equals x plus 0. The y-intercept is at 0. So I'll go ahead and put that in for fun. It's not necessary that you put that in. And I want to solve this via substitution. Now there's a reason why I put that plus 0 in there, because I want you to see that if you were to graph these, they have the same slope, but they have different y-intercepts. Now, if they have the same slope and different y-intercepts, it means that they're parallel, which means that they will never, ever touch. So if they never touch, how many solutions will they have? No solutions. Well, let me show you what it looks like when you try to solve a substitution problem with no solutions. So we're going to substitute in y equals x plus 2, but y also equals x, which means I can just set both of these equal. That's basically the general rule. Brilliant, but lots of people neglect it sometimes. So instead of y, I'm going to put in x. I'm going to substitute an x for this y. And I'm going to set it equal to x plus 2. Finish it off. Okay, get everything with an x on one side. 0, because x minus x is 0. It's not 1. It's not x. It's 0. 1x man minus 1x man is 0x man. 0x man is just 0, because it's 0 times x. 0 equals 2. When is 0 ever equal to 2? And the answer is, it's never equal to 2. And that's where students get frustrated. They say, oh, I didn't get an x equals 2, or x equals 0, or I didn't get a y equals 0, or a y equals 2. I got a 0 equals a number. I did this wrong. I'm like, no, you didn't. I'm like, well, what do you mean? I said, that was purposeful. When is 0 ever equal to 2? They're like, never. So what's, I know it, don't say. And they go ahead and they get really excited because they figured it out. I'll circle that too. Now we've done these problems in my earlier lessons too, so it should be review, but again, that was some time ago, so depends how quickly or how shortly you had looked at that. Let's try this one where y equals x plus 3, y equals x plus 3. They both have the same slope, they both have the same y-intercept. They're both the same equation. Now you can substitute in this x plus 3 for this y, or you can substitute in this x plus 3 for this y, since they're both solved for y. It doesn't matter. Just set x plus 3 equal to x plus 3. Subtract x on both sides, get all your x's on one side. 3 equals 3. Now I said, when is 3? And then some students say, no, 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 no. And then they subtract 3 on both sides and they get 0 equals 0. 3 equals 3 or 0 equals 0 means the same thing. You've got one value that's always equal to another value. Is the statement ever false? And the answer is no, it's not false. 3 is always equal to 3. If you subtract 3 on both sides, you're going to get 0 equals 0, which is always true too. And in either one of those two cases, since it's always true, it means that they're always going to cross, so the answer is all real x values. I used to tell my students to put all real solutions, but technically it's the theoretical answer is all real x values. But when you say something like that, then it gets students confused, and you do it one step at a time. You always clean up math, and then you clean it up and clean it up and clean it up more. But the most important thing is to be able to do the process and get a basic understanding. And then you just continue. So this is all real solutions. Actually, it's all real x values, but whatever. And that's a overview on substitution. Special cases, difficult examples, examples that students usually don't do right, and we've already done graphing, so we only have elimination. With that said, have a great day for now. Goodbye.